So here we are. We're cleaning off my gubby lens thing. This is the testing surface of the gold testing machine here. This is actually a pretty fancy one. The high dollar model. I bought it back when I had money. And so what you do to start off with is first of all, you use like 14 karat gold and you test it to see if it shows up. And it does. Trust me, it does. Um, it actually works. The darn machine, $600-700 machine now, works. And so what you do is you charge up this pen. It's got like a saline solution in it. And then it measures the resistance of the current going through. And so when I do this, it has no resistance, right? Because there's nothing in between. So it sees this as like a short circuit, and turns it red over there. All right, so, and here's something that I'm pretty much absolutely sure is platinum. and one of the things that we're checking here, what we're looking at, is the specific gravity. The more gold there is in something, the denser it becomes. So each one of these little increments is a step towards greater and greater density per unit of volume. 24 karat is 100%. And what'll happen here is this light's going to jump either here or here to these platinum ones, or it'll jump over here to 24 karat. And if I leave it on for any length of time, it it pretends like it's a short circuit. Oops. Okay, but it's not a short circuit, obviously. And when I do it quickly, it just goes over to the platinum. Or occasionally over to the 24 karat. Because it's both. This is AUPT. And it's mostly platinum in this particular instance. But there's enough gold in there to register as being 24 karat gold, because it is 24 karat gold, and it is also 24 karat platinum. And I get really quick readings with it because it's a good machine. So I can go like this, and it gives me the right information that way. I just touch it, and it says, platinum. Platinum. So Anyway, that's one of the reasons why, you spend a lot of money on these machines. And unless you do lots and lots and lots of tests with the same machine and with the other known quantities like the 14 karat, it's really hard to take the information given and make accurate conclusions from the information, because it left me with as many questions as I started out with, maybe a few more. And what I'm gonna do really is measure the specific gravity of this with my scale, and measuring the volume of water it displaces tells me its volume. So I can measure its weight and its volume and look at that ratio. The weight to volume ratio will tell me exactly what metal I have here. It should be 21.3 or something like that. Something like that. Something very much exactly like that. It will tip the scales at exactly 21.3, because this is, well, maybe not. You know what? There's some gold in there, so maybe it'll be more down in the 20 zone. Now, I have tested the AUPT dust before I melted it. And it is 20 on the specific gravity, 20 point something, and those points change depending on the mixture of gold to platinum, and most of the gold and platinum dust that I tested was stuff that I had pulled out. I screen it down to 300 microns, and I separate it out with a magnet. And I think this is stuff that I was testing early on. And this is stuff I made the other day out of the dust on the side of the road. And I got a whole bunch of it, actually. It's not just like one thing. I got a whole bunch of it. Hold on. So there it is. It is beautiful stuff, and we can move things aside here. Take a look. Because that there is platinum. Mostly platinum. This is AUPT. When you see it dark like this, it's got the gold mixed in. And this is, I have not cleaned this or anything. It's just a piece of stuff that came out of the melt. This one's kind of cool looking. Look at that. This comes from using Chinese teals of silver to start the melt. But that's not what it ends up with. Look at that. Isn't that cool? Because, see, that's moving through the metal. And metals move towards the heat. Okay, so as the silver is evaporating, it's pulling the AuPT out of the dust. It's a flux. The silver acts as a flux that pulls the metal from its dust variety into its metallic variety. Because as it hits that vapor point of silver, it's hitting the condensation point of platinum. Platinum starts to precipitate out almost right away. As soon as it starts cooling down from the blast of the plasma torch. It's big fun, actually. If you like that kind of thing, and I do. I do. I like things that get really, really hot, do neat things like this. This is a crystal of platinum. And this got so hot, it was literally a vapor. And as my plasma torch moved through it, with, hitting the silver first, right? It's torching the silver, but then it carries it into the AuPT dust. And that's what you see here. You see that the silver stuff gets blown away right through the AuPT dust. Man, I wish I could focus. And it it shows up in the way that you find the platinum. It's like, whoa, man, look at that. Because it is truly, truly, truly remarkable stuff, man. I realize most people think of platinum as being like really, really rare, and it is. My father told me, right? Nuclear physicist, multiple graduate degrees in physics and chemistry. He smart boyo, sort of. He told me platinum is 10 times more rare than gold. And that is pretty much what it says in the books too. If you look at the periodic table, the occurrence of different isotopes of platinum are listed in the number of of seconds or femtoseconds or whatever it is, or millions of years, or tens of millions, hundreds of millions of years, because there's a radioactive isotope of platinum with it's actually it has both alpha and beta emissions. Because the alphas are not really like participating in the chemical structure, the atomic structure of the platinum, so much as they're just stuck on the side because the platinum is so very, very dense. And it just absorbed those two little alpha particles, two little protons going by at light speed, and they just got stuck in the side there. And so I get a kind of blue glow from this stuff in my LED light. But the red, I'm only getting like you find it in these little nooks and crannies. The interstitial sites where the things that are different end up. So isn't that cool, huh? The way those do that? Because this is a crystal of platinum. And it grew in about 1 second, the less than 1 second. It grew out of a plasma. A plasma so hot that it vaporized the platinum. And gold is a vapor at that point in time. Platinum has a much higher melting point than gold, much higher, several hundred degrees, 700 degrees, 600 degrees. Celsius, right? 100 degrees is the spread between the freezing point of water and the boiling point of water. So 100 degrees is a pretty good spread. And 700 degrees is a lot of temperature. Gold melts at about 1050 Celsius, and platinum melts at 1768. And it's not easy to get there in any normal sort of way. Oxyacetylene doesn't quite make it. People who work with platinum use hydrogen as their gas, so that you get a hot enough flame to melt the platinum. I use a Cut 50 plasma cutter. I think I paid $135 from Amazon for it. And I use a high dollar graphite crucibles to hold the metal. I use this time, this particular mix here, I used calcium carbonate, basically, lime. but rehydrated lime, slaked lime. So it got dried out and then opened up in a moist environment. Boy, aren't those little drops cool? I mean, I think that is really cool. Yeah, that's really cool. You know that? I think that's really cool. So anyway, I think it's all really cool. Look at this stuff, man. I mean, and it's so white. They said platinum is a white metal, and you just don't understand until you see platinum. Because it sure enough is white metal. Look at that, huh? Boy. So what you're looking at here is probably the future of mankind. Because this is the dirt on the side of the road. This, not even, this was in the middle of the road, actually. And you know something? I mean, this is seriously dense material. It's more dense than lead. It's more dense than gold. Gold is 19 times more dense than water. This is 21 times more dense than the same volume of water. So this little batch here is probably a quarter of a pound, might be a pound, maybe, yeah, almost. It's a bunch. It's heavy. There's that. And then this one. And it is it's about a pound of this stuff, and I got that in just a few minutes of work. I mean, once I figured out how to do it, it just started accumulating because I was doing it the right way, and it accumulates when you do it the right way. Like cannabis, you grow cannabis, and by golly, you can just keep growing cannabis forever because they make seeds. And seeds are actually good. How about that? Seeds are good because they let you control the genetics of your plants. And sometimes you don't want medical. Sometimes you want the fibers and other stuff, oils. And there's all kinds of uses for all of it. So this is platinum. This is the most rare substance in the periodic table that people really want, because platinum has these the hoppers, and those hoppers create spaces where catalytic reactions take place. And that's those little squares that you see there. And those go all the way down to the very most fundamental structure of the platinum. As you can see, we're looking at a 10 by close-up of the surface of platinum, and you can see the little cubes. And those, when you turn electricity on through it attracts things like into those little spaces. And that's what creates catalytic reactions. And, for instance, every car on the road in the United States has a catalytic converter. And it has platinum around the ceramic little ball, and the platinum on the outside has these little hoppers. And as the ceramic heats up, that platinum glows white hot, right below the melting point of platinum, 1500 degrees Celsius. And then burns unburned hydrocarbons of long chain hydrocarbons from petroleum. So it doesn't work real good. It doesn't work worth shit. Which is why our air is all but unbreathable this time of year, and everybody gets the schnocks. Because, not because you're sick, but because the fucking air is foul. So anyway, and platinum is useful in hundreds, literally hundreds of chemical reactions where it's used as a catalyst, and it is probably the single most useful element we have. So, congratulations, boys and girls. You are rich, because this stuff is everywhere, man. Everywhere. And it comes out of the dust pretty easy, relatively speaking, and it didn't cost a whole lot. When you make aluminum, for instance, you gotta bump up to tens of thousands of volts to get the aluminum to break free from the oxygen, to get just plain aluminum instead of aluminum oxide. And breaking that oxygen free is not easy. And it requires some real caustic stuff, and the waste from that, the stuff that's left over is tremendously toxic. It is it makes steel making look almost clean. Aluminum is really foul shit. So, what we have here, this was a piece of silver, but it's now half the width that it was when it started out. And don't ask me how it did that, because I don't know. But it was twice this thick. And there you go, there it is. It's no longer that thick, and it's no longer silver either. That's platinum there, the bright silver part, and the rest has gold pulled into it, and maybe it's silver. Maybe there's still silver in there. But it gets so hot the silver literally vaporizes, and as it vaporizes, it pulls in, or the AUPT follows the heat and replaces the silver as it vaporizes.